Welcome to 5-Minute Math. This is Carrie Rhinehart, and today I'm going to be looking at transformations. If you're following along in the book, it's from Algebra 1, Unit 3, and I'm looking at Lesson 5, Part 2. So in Part 1, I looked at parent functions, or the main functions, for about 8 different types of functions. We looked at linear, quadratic, absolute value, etc. Transformations are just what have you done to the parent function to change it. Have you gone up? Have you gone down? Left, right? Has it flipped over the x-axis? That's all they are. And there's 3 main types. There's translations. And that just means that it's shifted. Okay, it's a shift up, down, left, or right. So up, down, left, or right. Okay. We also have dilations. That's when something is stretched or it's a shrink. Like if you were in Word and you were enlarging a picture or making it smaller when you put your cursor in the corner and you drag it. That's what a dilation is. So we look at those, that's either a stretch or a shrink. And then we also have reflections. That's if you're just flipping it over something. And for the most part, we're looking at reflections or flips over the x-axis. Flip over x-axis. So basically it'll be, instead of opening up, it'll be opening down because it's a reflection. To be able to tell by just looking at a function, for example, if I have f of x equals 2x minus 1 quantity squared plus 3. First off, this is a quadratic function because it's squared. And if you go back to parent functions, the parent quadratic is f of x equals x squared. So the differences between this and this, the first one in the parent is we've got this 2, we've got this minus 1 here, and we've got this plus 3. So there's 3 transformations going on here. The 2, the value that's out in front of a function that's being multiplied by that x squared, or the absolute value of x, that is your dilation. So that 2 is your dilation. If it is greater than 1, and we're not looking at the negatives yet, even if it's negative, ignore it. When it comes to dilations, you just look at the absolute value of that. So if it's greater than 1, then that's a stretch. If it's between 0 and 1, so like 1/2, that would be a shrink. But since this is greater than 1, this would be a stretch by factor 2. Okay. Then the minus 1, since it's in parentheses with the x, so whatever is, if it's happening to the x, it's in parentheses before the square or in the absolute value with the x, that is your left or right translation. And it's the opposite of what you think. Okay, it's minus 1, which means it's actually going to go right 1. With left and right, it's the opposite of what you think. So this is right 1. And then the value at the very end that you've added or subtracted, that is your up and down translation. So that would be what you would think. Plus 3 means you're going up 3. There is no reflection here. To be able to find a reflection, A, or the value out in front, would have to be negative, but it's not in this case. So let me look at one more example. So let's say we have f of x equals negative 1/2 absolute value of x plus 2 minus 5. So I've got 4 things going on here. I've got the negative, I've got the 1/2, the plus 2, and the minus 5. Because remember, the parent absolute value function is just this, the absolute value of x. The negative is a reflection over the x-axis. The 1/2 is a shrink by a factor of 1/2. It's a shrink because it's between 0 and 1. Remember, it'd be a stretch if it was greater than 1. The plus 2 here, since it's with the x, that's left to right, and remember, left to right is opposite, so plus 2 is actually left 2. And then out here at the end, minus 5, that is down 5. All right, I hope you guys have a great day.